Page 111, we're going to do some reviewing lessons 2.1 through 2.4. Also later in the video, I have some stuff starting on page 148, so you can fast forward to that if you're interested in that part of this more. But so on page 111, number 2, they want us to solve this equation. If you wanted to, you can add the opposite here. We've got like terms we can combine. Before we do that, we'd want to get a common denominator of 12. So this would be negative 8/12 d plus negative 3/12 d. And then if we combine those together, that'd be negative 11/12 d. At that point, you could say that they are multiplying, so we can divide. So if we divide by negative 11/12 on both sides, negative 22 divided by negative 11/12, so we can put that over 1, keep change reciprocal. Negative times negative is going to be a positive. If you want to reduce these, you can. If not, when you multiply and then divide it out, you should get the same thing. So that would be 24. So D equals 24. Always with these problems, if you have time, substitute that back in the original equation to see if it works. Number 3. So Edie has $450, deposits $40 each month. Juan has $975, writes a check for $45 each month. Also writes a check for $20 each month. After how many months will they have the same amount of money? So something like that to start out with. If you wanted to just look at overall how much Juan was spending on his bills each month, you could just add those together first, which would be $65. Nothing to distribute here, no like terms to combine on either side. If you like positive numbers, probably we'd want to add 65m on both sides. And then we can subtract to get the variable by itself. And then they're multiplying, so we can divide. And that would be 5. So after 5 months, they would have the same amounts. Number 4 asks which equation has infinitely many solutions. For us to get infinitely many solutions, we have to have the variables cancel, and then we also have to have the same constants on both sides. So for this one, that's 1 3/4 x. Over here is 2x. So the x's aren't the same. That would have one solution. The second one, we do get 3x on both sides, but one's got a minus 2.7, one has plus 2.7, so that would have no solution. On C, you can add the opposite if you want. That would be 7x plus 4.5. On the right side, we have constants we could combine, which would add up to 4.5. And then if you want to subtract 7x, you can. You do end up getting a true statement there, and so that would be our answer, would be C, infinitely many solutions. Number 4, if you are going to work this out, you need to distribute. Before you distribute, you may want to add the opposite here. And then we have like terms we can combine. And then we can get our variable on the other side, or our constant on the other side rather. They're multiplying, so we divide. And would be x equals 15. And then number 6, subtracted 8 from a number. So started with a number, subtract 8 from that, then multiplied that difference by 5. And the result was 20. So that would be our equation, and then to solve that, we'd distribute. And they're subtracting so we can add. They're multiplying so we can divide. And we would get 12. Hector's competing in a 42-mile bike race. He has already completed 18 miles and is traveling at a constant speed of 12 miles per hour when Wanda starts the race. Wanda is traveling at 16 miles per hour. So write and solve an equation to find when Wanda will catch up to Hector. So what we can look at is Hector is going 12 miles an hour times however many hours, plus he's already gone 18 miles. And then Wanda is just going 16 miles an hour. She's starting later than he did. We want to see when these are equal to each other. So we subtract 12h on both sides. And then they're multiplying so we can divide by 4. And that would be 4.5. So 4.5 hours until Wanda would catch up to Hector. Part B, will Wanda catch up to Hector before the race is complete? If you think about it, Wanda's going 16 miles an hour times 4.5 hours. Would be 72 miles. So it would take 72 miles until she catches up. The problem is it's only a 42-mile race. 42 miles. So the race is not long enough for her to catch up. So she would not catch up to Hector before the race is complete. And then part C, at what constant speed could Wanda travel to catch up with Hector at the finish line? So what we could do is look at Hector's 12x plus 18. If we set that equal to 42, that's going to tell us the minimum speed that she would have to go. So if we solve that, it would be 2 hours. 2 hours that Hector would take to finish the race. And so 42 miles divided by 2 hours she would have to go 21 miles per hour. So pretty fast speed she would have to go in order to catch up with Hector. Not starting at the same time as him. Pretty big deficit there. On page 148, we review on lessons 2.1 through 2.4. Lesson 2.1 is on combining like terms to solve equations. So we look at number 1. So here on the left side we have like terms. We can combine 2x plus 6x is 8x. So 8x equals 1,000. Then one more step, variables being multiplied by 8, so we can divide by 8 on both sides, and we divide is 125, so x equals 125 would be our solution for that equation. As always with these problems, if you have time, substitute that back in the original equation and see if that works out. So in other words, you could do 2 times 125 plus 6 times 125 and see if that equals 1,000. And it will. That's a confirmation to yourself that you got the right answer. If we go down to number 3, anytime on these problems when they're subtracting, if you'd like, you can add the opposite if you find that helpful. Add the opposite or change the sign, add a line. And then at that point we have like terms here we can combine again. We add those together would be negative 6.5x. So once again they're multiplying, so we're going to divide by negative 6 5/10. When we divide that, negative divided by negative is going to be a positive, and that should come out as 10 2/10. Look at number 4. Javier bought a microwave for $105. The cost was 30% off the original price. What was the price of the microwave before the sale? So basically, there's different ways you could think about this. One way to think about it might be that full price would be 100%. If we got 30% off, means we're going to be paying 70%. So we could say 70% of the original price is $105. So at this point, we're going to change the percent to a decimal. Just move your decimal 2 places to the left. Of usually means multiply. Original price is what we're trying to find. Probably we don't want to use O because that would look like a 0. I'm just going to use an X. Is usually means equals 105. At that point, we have an equation that we can solve. At this point, they're multiplying, so we can divide by 70/100. When you divide, you're dividing by something smaller than 1, so you're going to get a bigger number, and that should come out to $150. Okay, and then what we can do at that point is just test it like maybe you would have normally done. It's 30% off, so you could figure out, 30% of 150 is going to be $45, and then you could say, okay, 150 minus 45, and that gives me $105. So looks like we did that correctly. Lesson 2.2. We're looking at problems where we have variables on both sides of the equations. So just remember the steps we talked about when you're solving these. So maybe before we look at this, you can remember D, C, V, C, then divide. So distribute, combine like terms, variable on one side, constant on the other side. And then usually divide or multiply, just depending. So that's in your notes. You guys have that stuff. Anyway, so this problem, number one, we don't have to do all that stuff. Nothing to distribute here. So we do have some like terms we can combine on the left side. 3x plus 9x is 12x. Now we want to get the variable on one side, so we can subtract 6x on both sides of the equation. And then the last step is they're multiplying, so we're going to divide by 6. 42 divided by 6 is 7, so x equals 7. If we look at number 3, we got a similar setup. On this one, you can add the opposite here if you want. And then we can combine these together. So 9x plus negative 5x would be 4x. Next, we want to get the variable on one side. So usually it might be easier for you to get rid of the smaller one. Keeps things positive. So subtract 2x on both sides. And then once we've got that, we've got a two-step equation here. Next step's going to be get the constant on the other side. So we can subtract 18. They're adding, we're going to subtract. And then last step, they're multiplying, so we'll divide. It helps if you write the right numbers down here too. This is 34. So this would be 16. And then 16 divided by 2 is 8. So x equals 8. And that would be a thing if I would have done that. I got 7. If I had time, put it back in. It's not going to work. Then I know I messed up somewhere. Best thing to do if you mess up is restart on another piece of paper, because it's hard to look at what you did and figure out what your mistake was. Next, if we look at number 4, this one we have to set up an equation. So the question is, after how many weeks will they have saved the same amount? So the number of weeks is what we're trying to find. So we can let W represent the number of weeks. For Megan, it's $50 plus $5.50 a week. So $50 plus $5.50 times however many weeks. Connor, it's $18.50 plus $7.75 times however many weeks. And we want to see when these amounts are equal to each other. So this would be our setup for this problem. And then at this point, we're going to try to get, there's nothing to distribute, no like terms to combine on either side. So we can go ahead and subtract 550W on both sides. Gets our variable on one side. If this really bothers you, the order they have this, you can switch sides. Also, since these are being added, you could technically switch the order of those as well, if you like having the variable first. And then variable, we're trying to get by itself. So we want to get our constant on the opposite side. So subtract those, and then they're multiplying, so we divide. And that should come out to 14. So 14 weeks, they would have the same amount at that rate. Lesson 2.3 is on solving multi-step equations. So number one, the first thing we're going to need to do here is to distribute. Make sure you distribute to everything that's inside the parentheses. So that would be 4x plus 16 plus 2x. Then we're going to combine like terms on one side of the equation. 4x plus 2x is 6x. And then they're adding, so we can subtract 16. And then they're multiplying, so we can divide by 6, which would be 6. Any of these things too, you guys have worksheets. We did some problems that you could go back and rework some of the problems on those worksheets to get some more practice with these. Number 3, just to mention, if they bought some things 15% off, full price is 100%, 15% off means they're going to be paying 85%. So their calculator plus the binder was equal to 107.27. Calculator is 85% of whatever the original cost of the calculator is, which we don't know. The binder, 85% of the original price, which was $6.20. So if you multiply these, would be $5.27. And then we can subtract to get that variable by itself. And then they're multiplying, so we can divide. And that would be $120. Lesson 4, we looked at problems with no solutions or infinitely many solutions. On your tests, this is not going to be sectioned off. Basically, you're going to have problems to work out, and then you're either going to get one answer, or you say no solution, or you say infinitely many solutions, whatever the case might be. So number 1, first of all, you might want to put a 1 in front of that first x. Nothing to distribute here. Trying to combine like terms on one side of the equation. So on the left side, there's some constants we can combine. That would be 13 and 5/10. On the right side, if you want to add the opposite over there, you can. 5x plus negative 4x would be 1x. If you want to add the opposite here also, you can. You don't have to. And we want to get our variable on one side, so we subtract 1x, and what happens is it's going to cancel on both sides. So we got 13.5 equals negative 13.5. Those are not equal, and so we have no solution. There's no number we can put in place of x to make this equation work. Number 2, this one we do have distributing first. So half of 4 would be 2x plus 12. If you wanted to, on the other side, you can go ahead and combine your like terms together. If you want to add the opposite, you can. 3x plus negative 1x would be 2x. At this point, you might notice they're the same on both sides. We can subtract 2x on both sides. we get 12 equals 12, which is a true statement, which means we have infinitely many solutions. So any number we put in place of x would work. If we look at number 4, we have an expression for the weight of Abe's dog, where x is the number of weeks, and for Karen's dog, will the dogs ever have the same weight? So we can set these equal to each other and see what happens. So if you distribute first, so you get 2x plus 6 equals 3x plus 3. Then you can get your variable on one side. Subtract 3. You can divide by 1 if you want, you don't have to. X equals 3, so we can see after 3 weeks they would have the same weight.